I welcome you to the course on Six Sigma. In this particular session, I will provide the brief introduction of the course and the overall coverage, how we are going to cover it, and what are the various topics you will learn during this 4 months of your course on Six Sigma. So, I would just like to provide a brief introduction of mine. I am an associate professor with Department of Industrial and Systems Engineering, IIT Kharagpur. My areas of interest include supply chain management, Lean and Six Sigma, service operations management, project management, small and medium enterprises, and you can even contact me at my email ID. You can also see my publications in the different areas of industrial engineering at Google Scholar and home page. Let us discuss the structure of this course. Basically, the video lectures of this course Six Sigma are delivered by Professor Tapan on NPTEL, and myself, Dr. Jitesh Thakkar, is offering this course as repurposed MOOC course. The duration of the course is 12 weeks. The course is useful for mechanical engineering, MBA and industrial engineering students. Also, the professional working in manufacturing or process industry, service industry can also be benefited through this particular course. Student will be given a weekly assignment. There will be total 12 assignments. Assignment submission deadline is 10 days. The worked out solution in the form of video lecture will be released after 10 days. Instructor will address the queries of the student through Google Forum, and basically course includes one exam at the end of the course. Passing marks is 40. Tentatively, the structure of the question paper would be: section 1, some recall type questions, 20 questions, each one is of 1 mark. Section 2, assignment based questions, 20 questions, each is of 2 marks. And section 3, new within syllabus questions, and that could be of 20 question 2 mark, or 10 question 4 mark, or 8 question 5 marks. If you look at the course coverage, then basically this course is introduced to help the industry and working professional to bring systematically the improvement in the bottleneck or problematic area or functions, and this should be achieved within a stipulated period of time at a reasonable cost. So, a Six Sigma defect is anything outside of customer specification to be tagged Six Sigma. A process must not produce more than 3.4 defect per million opportunities. So, you can see it is just like approaching 0 defect, but statistically we would say that 3.4 defect per million opportunity. If your process can achieve this, then your process is called Six Sigma. You can think about various areas, for example healthcare, for example air industry, for example refineries, process industries, where achieving such a standard and low level of defect rate is extremely beneficial. There it is not only the cost, monetary component, but societal cost is also associated. So, Six Sigma is recognized as modern quality strategy to compete and sustain in the global markets. You can even think about a jurisdictory system where lot many cases in the country like India are pending, and if you devise an appropriate process which is controlled within Six Sigma, then the accuracy in the decision making can be improved. The philosophy of Six Sigma is basically built on two framework. One is called DMAIC, that is define, measure, analyze, improve and control, and DMADV, define, measure, analyze, design and verify. This course will provide a detailed understanding on both the methodologies to the students. The course intends to cover basic concepts in quality management, TQM, cost of quality, quality engineering, Six Sigma, review of probability and statistics and test of hypothesis. The course will focus on DMAIC process for process and design improvement, acceptance sampling, SPC, statistical process control, process capability, gauge reproducibility and repeatability and quality function deployment. Also, this course includes some of the advanced quality control tools like design of experiment, ANOVA, fractional, full and orthogonal experiments, regression modeling and Taguchi methods for robust design and Six Sigma sustainability. The course is basically designed with a practical orientation and includes cases and industry applications of the concepts. So, this will really help the people who are working in the industry or the students who are in the third year or final year and about to join the industry. They would be able to appreciate the concepts very well in the real life setting. Now, if you see the lecture plan, as I mentioned, there are total 12 weeks and the various lectures on the Six Sigma methodology concept are scheduled like this. Week 1 you will have 4 lectures. Lecture 1 will be quality concepts and definition. Lecture 2 key concepts in quality management. Lecture 3 fundamentals of total quality management and lecture 4 cost of quality and Six Sigma. Week 2 you will have lecture 5 fundamentals of statistics, lecture 6 probability theory and concepts, lecture 7 probability rules and events and lecture 8 sampling distribution and test of hypothesis. Week 3 lecture 9 quality philosophies and standards, lecture 10 tools for TQM and continuous improvement, lecture 11 quality function deployment, that is QFD, and design failure mode effect analysis, that is DFMEA. Lecture 12 will be on quality awards, benchmarking, service quality and so on. Week 4 there are again 4 lectures scheduled. Lecture 13 service quality and process control, lecture 14 project management complexities and examples, lecture 15 project management key decisions, work breakdown structure, schedule development and cost estimation, lecture 16 project planning scheduling, network critical path method, PERT and crashing. Week 5 you will have 3 lectures. Lecture 17 measurement accuracy and process variations, lecture 18 acceptance sampling, lecture 19 operating characteristic curve, week 6 lecture 20 design of sampling plan, lecture 21 basics of statistical process control, lecture 22 statistical process control for services. Week 7 lecture 23 control charts for variables and attributes, lecture 24 process capability fundamentals and measures and lecture 25 QFD and Kano model. Week 8 will include lecture 26 design of experiment, lecture 27 experimental analysis in product realization, lecture 28 experimental steps, setup and strategies. Week 9 will include lecture 29 on factorial experiment, ANOVA and response surface, lecture 30 benchmarking, customer service and product service performance, lecture 31 benchmarks and performance measurement, critical success factor and case study. Then in week 10 you will study lecture 32 supply chain management, TQM and quality chain, lecture 33 Taguchi product design approach, lecture 34 Taguchi's robust design. Week 11, Lecture 35, DMAIC, Zero Defect and Six Sigma. Lecture 36, Six Sigma Case Study and Tools. Lecture 37, Design for Manufacturing, Design for Assemble and Reliability Analysis. And finally, in week 12, you will have Lecture 38, that is FMEA, Failure Mode and Effect Analysis. Lecture 39, Six Sigma, Strategic Planning and Implementation. Lecture 40, Six Sigma and Operational Excellence Summary. We have many books in this area, but I would recommend few references that you can use in order to digest the content of video lectures and the assignments in greater depth. The book number 1 is Forrest Brackfog, Implementing Six Sigma, John Wiley. Then Howard S. Gitlow and David M. Levin, Six Sigma for Green Belts and Champions, Pearson Education. The third book is Evans and Lindsley, An Introduction to Six Sigma, Montgomery, and the final one is Mitra Amitava, Fundamentals of Quality Control and Improvement. So, we will discuss the various assignments and its solutions in each subsequent interaction, and you will also go through the various lectures as per the schedule. So, I congratulate you to for enrolling in this particular course and your interest in learning the Six Sigma methodology, and I would like to once again mention that this particular course will really help you to appreciate the real life industry problems and applications and how to handle them using the Six Sigma methodology. Thank you very much.